All right, so now we're going to move on to section 8.5. And in section 8.5, what we're going to learn is we're going to learn the law of sine. All right, so we are going to break this section down into two videos, video 1 and video 2. In video 1, you will learn what the formula is and why it works. And in video 2, we will do some problems. Now, before we show the formula or why it works, I just want to go over how we can apply the law of sine and what we'll learn next, the law of cosine. So before, if we wanted to solve for any parts of a triangle, it had to be a right triangle. Right? At first, it had to be a right triangle, and we needed to be given both of the legs, so let's say 3 and 4. And we can then use a squared plus b squared is equal to c squared. And we could solve for this side as 5. Then after that, we then learned about our Sohcahtoa. Which then we could use if we were given a triangle and we were given one degree measurement, say 40, and this side here, 5. Then we could then use Sohcahtoa to solve for the missing sides. We can then use it to solve for the other leg. We could then use it to solve for our hypotenuse. Before that, we actually learned our special right triangles of 30, 60, 90. So if we knew that this was 30 degrees and this was 4, then we knew this was 8 and this was 4 root 3. So that was all things that we learned. But the thing about that is they all had to be a right triangle. If they were not a right triangle, there's nothing we can do. So if I gave you this problem here and said that, well, this is 80 and this is 40, and I gave you that this was 5 and I asked you to solve for x, it was impossible for us to, because this wasn't a right triangle, so there was nothing that we could do. This problem here was something that we would not be able to solve. Well, what we're going to learn today with the law of sine, and what we'll learn in the next section, the law of cosine, we can now solve for any triangle. It doesn't have to be a right triangle. It could be the sides of any triangle. And then depending on which angles and sides you're given, it will tell us if we are going to use the law of sine or if we'll use the law of cosine. We won't be able to use both for any problem that we want. It depends on what information is given. All right, so now let's get started by showing the formula. We'll talk about what needs to be given to you for that, and then we'll go through and tell you why it works. We'll do like a quick little algebraic proof. All right, so let's go through the formula for this. So now it is the law of sines. So for any triangle ABC, let the lengths of the sides opposite the angles A, B, and C be A, B, and C. So capital letter A means it's the angle A, and then the lowercase letter a means that it is the side opposite of the angle A, and we'll call that side A. And the law of sine relates the sine of each angle to the length of the side opposite of it. So this is what you will set up. You will set up ratios, right? So it'll be sine of A over the side opposite of angle A is then equal to sine of B over top of the side opposite of angle B, which is then equal to sine C over top of the side opposite of angle C. But what you need to be given is you need to be given an angle and the side opposite of it. Right? If you're not given an angle and the side opposite of it, then you can never ever use law of sine. Right? So you have to know at least one angle and the opposite side. And then after you know that, you need to be given at least one other thing. So let's say if I want to solve for this side C, that means I would have to be given angle C. And if I wasn't, I can't solve for side C. And same thing, if I want to solve for, say, angle B, if I want to then solve for this angle, I would have to be given the side opposite of it. And the reason why is we will create these ratios or proportions. And in order for us to solve for this, we need to only have one unknown side. So if we were given angle A and side A, and then we weren't given angle B or side B, then we can't solve for either one of those. So you must be given an angle and the opposite side, and then whatever it is that you want to solve for, whether if it's side C, then you must be given the angle C. And if you want to solve for angle B, then you must be given side B. All right, so you must be given an angle and the opposite side, and then you must be given at least one other thing to solve for whatever you want. All right, now after this, I'm going to show you why it works, and then in the second video, we're just going to do some examples. All right, now let's go ahead and do a quick little algebraic proof for this. So let's just draw the same triangle that we just had. So in that triangle we had A, we had B, and we had C. And then I'll label the side opposite of A, CB, I'll label it A. Side opposite of B, I'll label that side B. And then this side here, I'll label it side C. All right, so now what we learned in previous chapter was we have what's called an altitude. So if I draw a line going from our vertex C that's perpendicular to the other side, I know that that is my altitude. And we also learn that that is the height of our triangle. All right, now by drawing that altitude, I created two right triangles. I created this right triangle here, and then I created this right triangle here. All right, so now with our right triangles, if I wanted to, I could highlight this angle A, and I know that H is my opposite side, and then I know that B is my hypotenuse. So I can say that sine of angle A is equal to my opposite H over top of my hypotenuse B. All right, and then from the other side, I can do the same thing, meaning I can then I know that this H is opposite of my angle B, so that's my opposite. I know that A will be that triangle's hypotenuse, so I can then say sine of angle B is equal to my opposite H over top of my hypotenuse A. Right, so now to prove this, what we do then is we're going to solve for H on both sides. So that means I'll multiply B on this side, I'll multiply A here, and I'll multiply A here. This B cancels out with this B, this A cancels out with that A, and now I'm left with B times sine of A is equal to H, and A times sine of B is equal to H. So since these two are both equal to H, that means that they are equal to each other. So I can write B sine of A is equal to A sine of B. And what we learned in the previous chapter is if we wanted to rewrite these as proportions, we could. I could then divide this side by A, which then means what I do to one side, I have to do to the other. So that will cancel out. And then if I wanted to move the B to the other side, I can divide each side by B. That will cancel out there, and I'm left with sine of angle A over A is equal to sine of angle B over B. All right, so that shows why these two work. And then if we wanted to, we could go ahead and draw an altitude going from angle A, say, to the other side, and we could then show that sine of angle C over C is equal to sine of angle B over B, and then that means by transitive property this will also be equal to sine of C over C. We're not going to go and show that one, but this here shows why the law of sine works. All right, and then we could do it again to show you why this last one works. We're just not going to do it in this video. You can do it if you'd like, just so you can see, and through transitive property we know that they'd have to be congruent. Or I'm sorry, that we know that they'd also have to be equal. All right, so now that is it for this video. And we're going to then use this and apply this in the next video.